Hi students, in this lecture I am going to discuss previous IIT questions. Let us see first one. In the circuit shown in the figure, given E1, E2, E3 and R1, R2, R3, and we have to find potential difference between points A and B and currents through each branch. Next, if R2 is short circuited and the point A is connected to point B, find the currents through E1, E2, E3 and resistor R. Right, let us see how to start the problem. Let us make first diagram. So given each of resistance 1, right, this is given E1, 3 volt, this is a 2 volt, and this is E3, 1 volt, and this is a point B, and this is point A, and this are all are equal to 1 ohm. So we have to find here VAB across AB, what is the potential difference? So here you can see there is no current flow in this resistor. Okay, because this is not a closed one. There is no flow of current in this one. That's why you can see at this point and at point A, potential same since there is no current flow. So I'm taking directly between this point and point B, what is potential difference? So to make calculation simple, I am taking at B potential 0. At this point, potential is V. That means now we have to calculate what is V value because difference becomes V minus 0. That is what we have to calculate. Now see how to solve it. And I want to take here Kirchhoff's first law at this junction. Suppose this current is I1 and this is I2 and this is I3. Now sum of the currents, or you can say the algebraic sum of the currents at a junction equal to 0. So I'm writing here I1. I1 means since this is a zero potential, this will be equal to 3 volt. Okay. This will be equal to 2 volt and this is equal to 1 volt. Right. Then see carefully potential difference V minus 3. It is V minus 3 upon 1. Resistance is 1. That is I1 plus V minus 2. V minus 2 upon 1 plus V minus 1 upon 1. That is I3. Algebraic sum equal to 0. From this we can get V value. So V plus V plus V, 3V. 3 plus 2 plus 1, 6. So 3V minus 6 equal to 0. That implies V equal to 2 volt. Okay. We got now V value. So from this we can write I1. I1 equal to. So we got 2 volt. This is 3 volt. This is high potential. So current flows left side. It is not right side. Left side. So potential difference is now 3 minus 2. That is 1. So 1 by 1. So 1 by 1. There is 1. This is 1. Direction of current is left side. Okay. Next I2. We can say I2 value 0 because 2 minus 2 0. Next I3. I3. This is I3. So 2 minus 1. It is 1. This is 1. Direction we have taken left side. It is left side. Okay. So first one is finding potential difference between points A and B. So we got V value 2. So potential difference between A and B is 2 volt, right? And we got now currents. Now see what he is saying in second one. If R2 is short circuited, its meaning is that just remove this one, or you can say connect one conducting wire across this. Okay, so remove this one. And he's saying that the point A is connected to point B. So connect point A to point B. Find currents through E1, E2, E3 and through resistor R. Redraw circuit once for the given condition. R2 short circuited. This is now E1. No change in this. And coming to here, this is a battery. Resistor is now short circuited. And next, this is as usual resistance and battery. So E1, E2, and E3. Okay, this is 3 volt. Now we are connecting the point A to B. Connect point A to B like this. This is now 1 ohm, right? This is now 2 volt. So we have to find now currents through E1, E2 and D3, also through R. Now see what we can do. This is also a very simple one. So here what I can say is between this point and point B, potential difference equal to 2 directly. I am repeating, students, between this point and this point, potential difference equal to 2. That means across this is 2 only. Across this also 2 only. That means this is now discharging and this has to charging, right? So potential difference, what I can write here? Potential difference V equal to, it is epsilon minus IR. In this, potential difference is now 2. This is 2. Across these 2 points is 2 equal to 3 minus IR. I can, this is I1 into R is 1. Or take it as I1 dash to avoid confusion. Here we have taken I1, I2, I3. I am taking here I1 dash. So from this we can say I1 dash equal to 3 minus 2, that is 1. So I1 dash equal to 1 ampere. Direction is left side. It is discharge. Next, coming to here, across this battery, potential difference equal to 2. But this is actually only 1 volt. Its meaning is this is not charging. Then I can write 2 equal to 1 plus IR. Take this as I3 dash. I3 dash into 1. That implies I3 dash is equal to, it is equal to 2 minus 1. That is 1. 1 ampere. Direction is right side. Okay. Next, remaining one is now it is 1 ohm, right? Now see carefully across this resistor potential difference at this point and at this point. Potential difference is now 2. Means across 1 ohm, potential difference is now 2. That means I2 dash is equal to 2 ampere. That current flows like this. This is I2 dash. So it is very simple and direct. Okay. Let us see now next problem. in an aluminum bar of square cross section. A square hole is drilled and is filled with iron as shown in the figure. You can see here, bigger one is aluminum, inner one is now iron, right? And given dimensions also. The electrical resistivities of aluminum and iron are 2.7 10 power minus 8 ohm meter and 1.0 10 power minus 8 ohm meter respectively. The electrical resistance between the two faces P and Q of the composite bar is. So this is a question asked in 2015 advance. Let us see how to solve it. So first we can say from diagram, both are now parallel combination. So effective value is 1 by R equal to 1 by R1 plus 1 by R, right? Then see carefully. It is just matter of making calculation. Resistance. Resistance R equal to rho L by A. Okay, now we are taking up resistance of aluminum. Resistance of aluminum that is equal to rho. See rho of aluminum. How much given? Electrical resistivity of aluminum 2.7 10 power minus 8. 2.7 10 power minus 8, that is resistivity of aluminum. Coming to its length, length is given as 50 mm. It is 50 mm means 10 power minus 3 rho L by A value. Coming to A value, you have to see carefully. We are making a hole and inserting iron into that hole, right? That means we have to focus now only remaining area, right? And that remaining area will be, it is given square cross section. Square cross section is area equal to A square. Given now 7 mm, 7 mm. So I'm taking 7 square minus, and that is now given 2. So 2 square, mm square means 10 power minus 6. See carefully, rho L by A, while taking A, total area from that subtract area of the iron. Okay, this is now resistance of aluminum. In the same way, resistance of iron, its rho value given as 110 power minus 8. It is given as 110 power, sorry, it is 110 power minus 7. It is 110 power minus 7. L value same, 50 mm, 10 power minus 3. And area is given now. It is simply 2 square, right? Into 10 power minus 6, mm square minus 6. Now effective value 1 by R equal to, since they are parallel combination, 1 by R equal to resistance of aluminum plus 1 by resistance of iron. Okay. So after solving this, we are going to get, it is 1875 upon 64. Okay. This is a micro ohm. So it is just a matter of taking the equation rho L by A, calculating both separately, then find resultant. Okay. See next one. Coming to next one. In the following circuit, the current through the resistor R equal to 2 ohm is I ampere. The value of phi is, so circuit is very simple one. Let us see once. Here I can say directly If you observe carefully in this part, 1 and this is 2. 2 and 4. So 2 by 4, 1 by 2, 1 by 2. It is 1 by 2. That means this is a balanced Weisstone's bridge, right? So we can remove 8 ohm. Okay. I will draw 1 second circuit diagram here to get more clarity. So first circuit given here. This is given R equal to 2 ohm through which we have to find the current. And next it is given here 6 ohm. And next this is a 6 ohm and this is a 12 ohm. Now connect these two here. And next here having one more, that is 1 ohm. And this is given as 10 ohm. See carefully values 1 ohm. This is a 2 ohm. And this is a 10 ohm. And you can take here along the diagonal two resistors, 2 ohm and next 4 ohm. And here taking one more, it is now 8. Okay. This is a 2 and this is a 4. Okay. Next coming to down one, here having one more, that is 4. 4 ohm. Now see carefully. In this, you can see 1 by 2, 2 by 4, 2 by 4, 1 by 2. This is 1 by 2, means bridge is balanced. So we can remove this 8 ohm. Okay. That means now what happens is, we can see 1 and 2, that becomes 3, 2 and 4, this becomes 6. That means 3 and 6 are parallel. Therefore, this effective value, this effective value will be, that effective value will be equal to 2 ohm. I am repeating, this is 3, this is a 6. 3 and 6 are parallel. So effective value 2. Okay. Now see once again, 2 by 4, 1 by 2, 6 by 12, 1 by 2. That means this is again a Wheatstone bridge, which is balanced. So we can remove now this 10 also. Now remaining is only 6 and 12 series, 2 and 4 series, 6, 12, 18, 2, 4, 6. These two are parallel. So it is now 18 into 6 by 24. Effective value 6 4 times. It is 9 by 2. Now this entire value is now 9 by 2. For 9 by 2, 2 is now in series. So total value 9 by 2 plus 2. So it is now 9 plus 4, 13. 13 by 2. That is now effective resistance. And we are given this is 6.5 volt. Therefore, current equal to 6.5 volt upon 13 by 2 means 6.5 ohm. It is equal to 1 ampere. So 1 ampere current flows now through this one. Okay. That is simply having two Wheatstone bridges in same question. If you are able to identify that, it is very simple. See next one. Right, see the question. Two batteries of different EMFs and different internal resistances are connected as shown. The voltage across AB in volts asked in 2011 advance. Now see carefully. 6132 given values. Given 6 volt 1 ohm. Next one is given. It is 3 volt 2 ohm 3 volt 2 ohm. Now across AB, what is the potential difference? Now see what we can do. First of all, calculate what is the current in the circuit. So to find current in circuit, what we are doing is take now Kirchhoff's second law. Let us take current is now in this way. It is I. Now see carefully. Take the loop equation. We are moving along the current flow. So from high potential to low potential. So I'm taking -3. We are moving along the current flow. Therefore, minus 2 into y, because high potential to low potential. Next, again, along the current flow, minus I into 1, IR. Now, low potential to high potential plus 6 equal to 0. That means I equal to, it is 6 minus 3, 3 by 3. It is 1 ampere, right? So you can see here, this is 6-volt battery is discharging and 3-volt battery is charging, right? So between A and B, potential difference. Either we can write 6 minus I into R, that is a 5. Otherwise, we can write 3 plus 2 into 1, that is equal to 5. So one is a discharging and one is a charging. Okay. Right. Now see next one. For the circuit to shown in the figure, so we have to find current to I through the battery, potential difference across RL, next ratio of powers dissipated in R1 and R2. Next we have to calculate this if R1 and R2 are interchanged. Magnitude of the power dissipated in RL will decrease by factor of 9. Okay. So these are the things we have to verify, right? Let us see. So first see circuit diagram once. So circuit diagram is this is now 24 volt. They can get 2 kilo ohm. This is given as R1 whose value is 2 kilo ohm. Next it is R2. This is given as 6 kilo ohm. And parallel to this having one more, that is now RL, which is given as 1.5 kilo ohm. This is now circuit given, right? First, we have to find what is the current. We have to find what is current. I value. C1's effective resistance. 6 and 1.5 parallel. It becomes 6 into 1.5 by 6 plus 1.5, 7.5. 1.5, 7.5, 5 times 6 by 5, 1.2 kilo ohm. And that is now in series with the 2 kilo ohm. So total value 2 plus 1.2. That means I value will be equal to 24 upon 3.2 kilo, or I can say it is a minus 3 here, and that is equal to how much? 7.5 milliampere, right? So first option is correct. Next, asking potential difference across RL. Potential difference across RL. See how to find it. This effective value is now 1 point, right? Now that is in series with this one. In series combination, I is the same, current is same. So V proportional to R. So I am writing here V proportional to R. So this is now V value across the load resistor VL equal to proportional to R. So I can write 1.2 by 1.2 by 3.2 into 24, right? That is now potential difference across load resistance, which is equal to, see carefully once, 1.2, 3.2. 4 table at 3 times here, it is 8 times 3 by 8. 3, 8 and 8 here 3 times. This is 9 volt. But option given is 18. So that is not correct. Option B. Next, ratio of powers dissipated in R1 and R2. See how to calculate that. Ratio of powers dissipated in R1 and R2. Coming to R1, coming to R1, we can write power across R1. I can write V square by, or I can write I square into R. That is more easy, right? I square into R. I value 7.5 milliampere. I square R value 2 kilo ohm. Okay. Next, calculate across R2. Across R2, we have to see this current 7.5 divides, right? Since they're parallel, it is in the inverse ratio of their resistances. So I can write here 7.5 milliampere into, we have to calculate now R2, right? So it is now 1.5 by 7.5. Okay. So I square into R value 6 kilo ohm. Okay. We have to calculate ratio of powers. So when you are taking ratio, 7.5, 7.5 gets cancelled. Here 1.5, 7.5, 5 times. That is now, first we are going to get here PR1 upon PR2 is equal to 2 by 6. This is 1 by 5 whole square. It is a 5 square, right? So 1 by 3, 25 by 3. I think calculation is okay. Ratio. Okay, I square R. 7.5, 7.5. 2 by 6 I have taken directly here. It is remaining is 1 by 5 whole square. 1 by 5 whole square. It is 5 square. Okay. And here it is 3, which is not correct. Next we have to calculate. It's asking that if R1 and R2 are interchanged, magnitude of the power dissipated in RL will decrease by a factor of 9 in RL. Okay, let us do first of all in RL what is the magnitude of power? RL, power calculation RL before interchanging power in RL I square R. I can write I square R, I square R, R L. See what we can write here. Or I can calculate here directly potential difference across this one and across this one, right? Potential difference will be, see how much you get. This is 2 and this is 1.2. Potential is proportional to potential. How much we got here? It is 9, right? So this is 9 we got across the this one potential 9. So I can take directly this result here. B square, it is 9 square, 9 square upon 1.5 kilo. This is before interchanging. Okay. Let us calculate now after interchanging. Let me see once VL. We made a calculation at VL already 9 using that here. Now, if you see, if you interchange, given interchanging R1 and R2, R1 and R2, that means now this becomes a 6 kilo ohm and this becomes now 2 kilo ohm. Then see what happens coming to the potential across this. So first I'm focusing here what is the effective value. Okay. This effective value is now 2 into 1.5. I'm making here 2 into 1.5 upon 2 plus 1.5, 3.5. That is equal to, see how many times? This is 3 and this is 7. Total is now 6 by 7 kilo ohm effective value and this is now 6. So now potential will be in the ratio since they are in series combination. Potential will be in the ratio 6 is to 6 by 7 or I can take it as 42 is to 6, right? So potential divides in this ratio and we want across the load. So here what we can do is that potential is now that potential across the load equal to 24 into 6 by 48. This is now 2 times. This is equal to 3. Now power across the load resistance in second case. Okay. I am taking as dash here. That is equal to 3 square upon 1.5 K. Now compare. This is 9 square. This is 3 square. That means it has decreased by 9 times. So option D is correct. Okay. And see next one. See the question carefully. Incandescent bulbs are designed by keeping in mind that the resistance of their filament increases with the increase in temperature. If at room temperature, 100 watt, 60 watt and 40 watt bulbs have filament resistances are 100 or 60 or 40 respectively. The relation among these resistances is asked in 2010. I think this we can say directly. We can see what is meaning of 1 by R. We are knowing that P equal to V squared by R. I will write here once. P equal to V square by R. That means 1 by R is 1 by R is 1 by R is P by V square. For all V values same, this is nothing but marking. Okay. For example, it is like 100 watt, 220 volt, 60 watt, 220 volt, 40 watt, 220 volt. This is fixed. So in our country, this value fixed 220. So V value fixed. So 1 by R equal to P by V square means if P value more, 1 by R value is more. Right? That means 1 by R is more for 100, next 60, next 40. See once. Option D, right? First 100, next 60, next 40. That is a very simple question. Option D.